Hi friends, you are welcome back to another interesting question. We are asked to calculate the area of this trapezium. We have the length of this line segment to be 15 units. That of this is 60 units. This here is 30. And here, this line segment and this are congruent. We have 3 right angles. So how can we solve this? How can we determine the area of the trapezium? It is very simple. We first come here, assume the length of the congruent line segment to be x each. Let this be y and this z. The general formula for calculating the area of a trapezium is 1/2 times h, where a and b are the length of the parallel sides and h is the height, that is the perpendicular distance between the parallel sides. Here we see this side and this both are perpendicular to this side. That makes them parallel, and this side is perpendicular to both parallel sides. Hence it is the height h. If we let this be a, this must be b. So h equal to x plus x, which is 2x, equal to z. We substitute it here. This 1/2 multiplied by this 2x is x. Y plus c times x is x into bracket y plus c. So area of trapezium equal to x into bracket y plus c. Now come here. From this point A, draw a straight line to this C, and from here to this point, look at this triangle. It is a right angle triangle. This side is its hypotenuse, as it is the side facing the right angle. Same as here, it is a right angle triangle, and this side is its hypotenuse. Back to this triangle, the proportion between the legs is 30 to 15, which is the same as 2:1. Same as here, the proportion is also 60 to 30, that is 2:1. That implies that the two triangles are similar triangles. So if we let this be R, this must also be R. Still here, based on the rule that the summation of angles in a triangle is 180 degrees, since this is a right angle and this is R, this must be 180 degrees minus 90 degrees minus R. 180 degrees minus 90 degrees is 90 degrees. So the angle is 90 degrees minus R. If you notice here, the size of angle ACE is summation of R and 90 degrees minus R. R plus 90 degrees minus R is 90 degrees. So the angle is a right angle. Now come here, this line AC and this EF, we extend it till they intersect. Here we see this angle and this are formed by two straight lines intersecting. That makes them vertically opposite angles, meaning they are congruent. So if we let this be E, this must also be E. Now look at this triangle. It is a right angle triangle, and it has one of its angles to be E. Same as here. It is also a right angle triangle, and it has an angle E. That makes the two triangles similar, but this side and this being congruent promotes them from just being similar to congruent triangles. Therefore, this side and this are equal in length, and this are also equal. So since this is y, this must also be y. If we let this be m, this must also be m. We take a look at this triangle. We have this median bisecting this side. That makes it a median of the triangle. But we see it is also perpendicular to the side it bisects. The only two triangles that have a median perpendicular to a side are the equilateral triangle and the isosceles triangle. It doesn't matter which one it is. In both equilateral and isosceles triangle, such median is also an angle bisector, and the sides of the triangle adjacent to it are congruent. So here, this angle and this are equal. Since this is r, this must also be r. And also, this side and this are congruent. We have this to be the sum of 15 and 60. Therefore, this side must also be 15 plus 60, which is 75. Now look at this quadrilateral. This angle and this are equal and opposite to each other. So we have a pair of equal and opposite angles. We see this line is a diagonal and it bisects this angle. This is a property of a kite-shaped quadrilateral. It is also common in a square, but it's not the case here. So the quadrilateral is a kite. Therefore, this side and this are congruent, and this are equal. So since this is 60, this must also be 60. Therefore, z equal to 60. And since this is 30, this must also be 30. So x equal to 30. That is, this side also 30 units in length. This side, its full length is 75. We have this part to be 60. Therefore, this must be 75 minus 60, which is 15. So y equal to 15. Now we have y equal to 15, x equal to 30, and z equal to 60. Substitute it here. Area of trapezium equal to 30 into bracket 15 plus 60. 15 plus 60 is 75. 30 times 75 is 2250. So area of trapezium equal to 2250 square units. Thank you for watching. Please like, share and subscribe, and also turn on notifications. Thank you.